Howdy folks, thanks for tuning in. We're picking up here again with the rebuild of this Tesla large drive unit for a Toyota RAV4 EV. If you didn't see the first part of this video, make sure to go back and check that out first. In that video we pulled the drive unit out of the car and disassembled it all. This drive unit had a seized rotor in the stator from a buildup of basically just rust and corrosion from coolant intrusion, which is a real common failure mode for these drive units. Anyways, so what we're going to do in this video is we're going to continue with a little bit more disassembly. We've got to get the other rotor bearing out of the inside of the motor case here. We've got to remove the other bearing from the rotor, as well as the bearings for our primary drive gear. And I should have those showing up in the mail tomorrow, the replacement bearings. I've got a batch of them coming in. And we should be able to complete reassembling all the bearings on there, clean out all the corrosion in the stator and on the rotor, and then we can put everything back together, get it into the car, and take it for a test drive. Alrighty, so we've got our motor case assembly here with the stator. If we take a look inside, you can see all of the rust and corrosion on the steel bars in the stator here. So we'll have to clean all that stuff up. We also have to remove that bearing down there. That bearing is one of the rotor bearings. Normally both of them come out with the rotor when it comes apart, but I've had some occasions where it does stay stuck in the case half. We also need to take, of course, the other bearing off of the end here. This is the end of the shaft where that seal would normally go. And this bearing is kind of the first thing that gets exposed to coolant. You can see the grease coming out of it here. And you can see it kind of gets pushed out from the back side by the coolant running through it. And while it doesn't really currently have any present major noise issues, it almost certainly would at some point in the future, because the races on this bearing could potentially start to get a little bit of rust buildup, but with the grease washed out of it, obviously it's not going to last nearly as long as it would if everything were intact. And of course we have a little bit of corrosion on the outside of the steel laminate on the rotor here itself, so we'll have to clean that up as well. We've got our primary drive gear here, so we'll go ahead and replace this bearing as well as the other bearing for it that sits in the case half here. That's just standard practice for me. It's real common that the primary drive gear bearings and the rotor bearings can end up having noise issues. And so anytime that I have one of these apart, it's always best just to replace all four of those bearings. Even if it's not a currently present noise issue, it's a good thing just to do them. Really the majority of the cost to rebuild one of these things is the labor cost. The bearings are realistically a relatively smaller part of the cost of the rebuild. So I think the combined cost for all four of these bearings, all four of which will be hybrid ceramic, so both the rotor bearings and the primary drive gear bearings will be hybrid ceramic, which that's an upgrade for the primary drives. They don't do that from the factory. I think the combined cost for all of those to the customer is going to be somewhere in the neighborhood of about $800 for all four of those bearings, which sounds like a lot for bearings, but for hybrid ceramic bearings, that's kind of about what the going rate is. And yeah, that's pretty much it. So we'll get to pull that bearing out. We'll start cleaning up all the corrosion in here as well as on the rotor, and then we'll get to swapping out some bearings. Alrighty, so we're gonna pull this rotor bearing out of here. I've got a puller here called a Cuco. Normally I use this on the primary drive gear bearing that's in the case half there. Especially on early motors, those bearings can be really stuck in the case, and these Cucos are the only pullers that I've ever encountered that basically don't break on like the second or third use. Yeah, they're just really high quality. But anyways, so I'm going to use this puller to pull that bearing out. However, the jaws are just a touch wide in here. So I can fit it in, but the jaws end up covering the top of the bearing just ever so slightly. So I can't actually pull up on it. So what I have here is I just have an old bearing race from an old primary drive bearing that I'm kind of going to use as a spacer. And that'll give enough distance that I can pull the bearing out even though the jaws are slightly obscuring it. So we'll go ahead and get our puller kind of set up here. Okay, and that's in. So we'll spread the jaws out, get our arms kind of positioned where we want them. That seems pretty good there. And now we want to draw our jaws up till they contact the bearing. And then we'll get our wrench on here. And see if we can pull this thing out. Shouldn't be too terribly stuck in there. Usually these rotor bearings come out pretty easy. There we go. I think we're out. And there we go. So there's our rotor bearing pulled out. And now let's move on to the next. Alrighty, so now we can move on to the primary drive gear bearings. So first we're going to pull the one out of the case half here. And of course you can see our counter gear bearing that was loose when we pulled the gearbox apart from the last video. We'll reinstall that and get it glued back into place like it's supposed to be when we install the new bearing here. But first, we've got to pull the old one out. And of course, we'll go back to the trusty old Kuko. Like I was saying before, on the older cases, these bearings can be a real bear to pull out. But this is a newer build motor, so I don't think it's going to be much of a problem in this particular instance. So we'll go ahead and get that set up. Get our jaws spread apart. And now we can tighten that down and pull the bearing out. Yep, and it's coming out pretty easy. On the older cases where these are really stuck in there, the only way that you can get them out is just to really crank on them with one of these pullers and then heat up the case around the bearing race and try and get it to pop loose. Once it pops loose, they come apart without too much difficulty, but getting that initial bump out of it is really difficult. The bearings are glued into the case with some of that green Loctite bearing mount compound. And I think that the tolerance for the bore on the old cases is just a lot tighter and it makes them super difficult to get out. But they're nowhere near as bad on the slightly newer cases. Alrighty, so that one's ready for the new bearing when those come in, hopefully tomorrow. Now we can do the other one on the primary drive gear itself. Alrighty, so now we've got to get the bearing off of our primary drive gear here. So first we got to loosen off this kind of spanner collar nut. These are Loctited on, so they can be a little bit difficult to get off. And of course we want to make sure that that gets Loctited back on, because I have seen these back off before when they've been installed without Loctite. Okay, there's that. And now we can go ahead and pull the bearing off. Alrighty, so we'll get our puller set up here. We've got our socket as a spacer there. And then we'll tighten down the puller. And then we'll just crank this thing off. Alrighty, and now that's ready for the new bearing when they arrive. Alrighty, so now we've got to clean out all the corrosion in the stator here. There's a bunch of kind of gunked on thick buildup of rust in here. I find that the best way to get that portion of it out is just with kind of a long flat blade screwdriver and just kind of scrape it off in chunks. Just like that. And then once we get all the, kind of the big chunks off, then we'll go through with kind of like a fiber abrasive wheel on a drill and then just kind of clean it all up some more. And then I'll spray it down with some electric parts cleaner and wipe everything dry. And then at that point, we should have all the corrosion out of it. So let's get started. Alrighty, that looks pretty decent. There's a couple of areas that I might need to come back and touch up a little bit, but I got it about 90% done. Alrighty, so I spent a little bit more time on the cleanup portion of the stator here. You can see there's a couple little spots where we still have a little bit of discoloration, but there's no raised areas. It's all nice and smooth. So that's ready to be put back into service. Alrighty, so our next step is we've got to go ahead and clean up our rotor. First things first though, I have to reinstall the bearing back on here. And then I'm going to get this thing kind of on my little cobbled together V-block set up here so that we can spin it. So let's go ahead and get that bearing on there. I'm just going to reuse the old bearing because I don't have the new bearings in yet, and also I wouldn't want to cause any damage to the new bearings. So we're just going to use the old bearing for this. All right, that's installed. And we've got it on the blocks there. Let me get you moved over. Alrighty, so now that we've got the rotor on the V-block set up here, we're gonna go ahead and spin it. I always just take a socket with a piece of hose stuck on the end of it, and I stick it on the inside end of the rotor and just spin it up with a drill. Just like so. So now it's spinning. Now again, we had some kind of big chunks stuck on there, so I'm going to kind of do the same thing, obviously with some eye protection. And we're just going to try and chip off the big chunks. Okay. And now we'll take our abrasive wheel and we'll clean it up the rest of the way. Looking pretty good there. Still just a little bit of mild discoloration, but again, no raised areas. Probably hit this just a little bit more, and then I might go hit it with a little bit of 500 grit sandpaper. Alrighty, so now that we've got the rotor cleaned up, we can pull the old bearings back off again in preparation to put the new bearings on. I always start on the shaft side because if you have your puller set up to pull this bearing off, by the time you pull it off, it'll be set up almost perfectly to pull off the other side. Anyway, just kind of a trick that I've learned from doing these over the years. So we'll go ahead and get our puller on here. We'll get it tightened down. And then we can just pull that right off. Okay, there's the first one. And of course, since this is a hollow shaft on this end, we've got to have kind of a spacer to go in there. And then I'll just do the same thing again. Boom. All right, so there's both of those off. And now that's ready for the new bearings when they come in. Alrighty, so now that we've got all of our old bearings removed, now we can start cleaning everything up to get it ready for reassembly. So everything here is just assembled with just some RTV silicone gasket maker. So all the old stuff just has to be scraped off. My personal preference for this is just to use a scraper blade, remove all the old material, scrape everything off, and then I'll just, hit everything with a little bit of acetone to make sure there's no oils or anything on it, and then it'll be ready for reassembly. So not going to go too into detail with this, probably just time lapse through everything. So here we go. Howdy folks, it's a new day and we've got our fresh new bearings in, so we're going to go ahead and get those installed. First we'll do our primary drive gear. I've had this chilling in the freezer just to make it a little bit easier to install the bearing on it. Of course, anything expands and contracts with temperature. In the case of steel, it's usually about 1/1000th of an inch for every 100 degrees Fahrenheit. So by freezing it, you can get it to shrink just a little bit. So we've got our fresh new bearing here. This is of course, a hybrid ceramic 6208 bearing. We'll get it on there as far as we can, and we'll go ahead and get it into place. All right, so that's fully installed on there. And now, of course, we have to install the nut on it with some Loctite, some red Loctite. This is very important because without the Loctite, these things can come apart and destroy that seal in the gearbox. And then it will literally pump all of the oil out of the gearbox and into the motor, which doesn't really hurt the motor since the oil is non-conductive, but it will destroy the gearbox. And especially for the RAV4 and the B class that have the special reverse rotation gear set, you obviously don't want to destroy those since they're very difficult to find replacements for. All right, that one's good. Now we'll do the one in the gearbox case half. Alrighty, now we need to, of course, install our other primary drive gear bearing, and we also have to reinstall the counter gear bearing here that came out when we disassembled everything. So these two bearings just get pressed into place. They're not a super tight fit, and they need to have some of this green retaining compound put on them. So we'll just put a little bit of that on the outer race here. And then I'll just kind of lightly spread that out a little bit. And that goes right into position like so. And that gets driven home. Just like so. And then we'll do the same with our new primary drive, which of course, just like the one on the other side, is also a hybrid ceramic. Clean up any excess mounting compound around the edges here. It got squeezed out. Now that side is good to go. Now we'll install the rotor bearings. Alrighty, so continuing on, we're going to go ahead and install the new rotor bearings. And of course, just like everything else, these are a hybrid ceramic non-conductive bearing, but of course these ones are sealed and lubricated with grease. So these are also pretty simple to install. We'll just get it started on the shaft there, and then we'll bring it home. Alrighty, that's all the way on. Now we'll flip it around and do the other side. Alrighty, and now that one's installed as well. Alrighty, so now that all of our new bearings are installed, we can go ahead and start reassembling the motor. We'll start with the gearbox. And of course, just like we did with the disassembly in the last video, we are going to go ahead and install the primary drive and the counter gear simultaneously. And once again, just like before, we don't want the gear teeth to get jammed up against one another. So we kind of need to do these two in unison. And it's just a little bit of a tricky process, but it's not too terribly difficult. To start with, I'm going to have the primary drive kind of sitting down here a little bit to the side. We'll get the counter gear in started just a little bit, and then we'll be able to get the primary drive kind of back in line with it along the side there. So I find that the simplest way to do this is just with a long flat-ended punch, and we'll just drive the outer race of the bearing in to place, just lightly tapping it around. We want to make sure we stay nice and level. And once we get that one started, it needs to go just a tiny bit more. We can get the primary drive lined up with it. There we go. So now they're both lined up there, but we still need to drive this one in a little bit more because, again, we don't want the teeth to get jammed up against either of the gears or the bearings. We just want to go down a little bit with this one, then we'll do the same back and forth, keeping everything meshed together. I'm not hitting this very hard. I'm just kind of lightly tapping, going around kind of in a circular pattern. All right, so we've gone about as far as we can go there. So now we'll do the same with the primary drive. All right, so that's about as far as we can go. And now, again, we'll just go back and forth between the two. All right, so both the primary and counter drive both the primary and counter gears are installed now. Go ahead and get our oil pump back into position here, where it's supposed to be. All right, that's in. So now we need to install the fasteners for that, as well as our bearing retainer plates for both gears. Alrighty, so there's all that fastened down. We'll go ahead and get our differential gear in. This has the bearing retainer kind of pre-attached to it. The two studs that are furthest apart kind of face towards the counter gear. And usually these ones drop into place pretty easily once you get it lined up properly. Might need to give it just a couple little love taps. And again, we don't want to hit anywhere on the gear itself. We want to hit at the outer race of the bearing. There we go. Dropped right into place there. And then the last thing that goes in here, which is very important, is the oil pump gear, which just has an indexed little flat spot on the pump there. There's no timing or anything on this, so the position doesn't matter. It's just a basic pump. And then that little E-clip gets snapped into position. Just like so. Now we can get all of our O-rings in place, lay down our bead of silicone around the whole thing, and then we can drop the other half of the case on here. All right, so our bead of silicone is laid down. Now we can install our other case half. Pro tip when installing the case half for a B-class or RAV4 with the parking pawl mechanism, make sure the parking pawl is unlocked so that you don't get the hook caught on the star wheel here. Get our wire harness fed through there. And then this should just drop on pretty easily, just like so. And then we'll go ahead and get all of our fasteners in. This is the quick setup gasket maker. So this stuff does not require any setup time before torquing these down, although that also means that you need to work pretty quickly when getting it put together. By the way, this is the gasket maker. Right stuff, 1 minute, return to service, black gasket maker. That's actually the recommended stuff that essentially Tesla uses. I'm not getting these super tight just yet. I'm just kind of snugging them down. Oops. Got to reverse that. All right, now I'll just hit all these by hand and get them torqued down. Of course, you can't really see it, but on this side there's the little bracket that goes on top that's specific for just the RAV4 that gets bolted underneath those two bolts just above the differential. Alrighty, so that's all assembled. Before we flip our motor over, we'll actually pop this axle seal out of the gearbox and install a new one of those. There we go. New seal. That is perfect. Flush with the surface there. And now we can flip this over. In preparation to put the rotor in. All right, we're just about ready to put the rotor in. First though, got to make sure to grease the splines. Don't want to assemble that dry, otherwise it will have spline wear issues in the future. So I'm just gonna put some grease on the inside of the primary drive there, and then I'll go and get some on the rotor as well. All right, we've got our splines all greased up, and now it's time to put the rotor in. So I always just kind of set it on the edge like so. Kind of get it started in here. And then I just kind of let it drop into place. And you can see it just slid right in all the way to the bottomed out into the splines. Sometimes you'll bottom out and it won't go into the splines. You can kind of tell when it goes in, but it should be the face of the rotor, at least for these later style rotors that are flat on the ends, should be, I don't know, maybe about an inch or so from the face of the actual stator. So now I'll go ahead and flip this all the way vertical. And we can go ahead and install our nuts for the differential bearing retainer. Go ahead and do all those real quick. These are actually just a nut that has it's almost like a reverse lock nut, for lack of a better term. They have plastic on the back side instead of on the front. And that just seals the holes and the threads where these poke through the gearbox case. And of course that one we can't really get to very easily, so we'll have to do that one the old-fashioned way. Alrighty. And then we're also, of course, going to go ahead and replace the axle seal on this. So we'll just pop that one out and drive the new one in. Perfect install. So now that that's all done, we can get ready to install our end cap. There are some spacers that go in here. It's got a couple of Belleville washers, and then an additional, just a spacer. The spacer faces towards the bearing race. So those just go in there like so. And then of course we have an O-ring that goes there. And we'll go ahead and install our ring of silicone on here as well. All right, and now we can go ahead and install the end cap. And this just pushes into place pretty easily. Get our fasteners in it. And once again, I'm just gonna kind of snug these down. Now we'll torque this the rest of the way by hand. Alrighty, so now we're on to kind of the final stages for the motor assembly, including one of our most important parts. First, we've got to install our reluctor wheel. That's the pickup for that rotor encoder sensor. So we'll just kind of lightly tap that into place. That's in. And now, instead of reinstalling the original manifold with a seal here, which of course was the failure mode that caused all the issues here in the first place, we're going to install a rotor coolant delete manifold. So this is of course an aftermarket manifold that we offer here, and that I played a major role in designing. But effectively this does the same thing that Tesla's newest U revision large drive units have, which is just a factory version of rotor cooling delete. And basically what that does is it just bypasses the circuit for the rotor cooling that would normally go through this tube, and instead it just bypasses and goes straight through the flyover tube that comes out of the top here over to the top of the gearbox. So anyway, that's what this does. This one also has the option, there's some extra ports on here to be able to add oil cooling for the rotor. For 99% of applications, it's probably way overkill, but if someone's building a race car or tows a trailer around all the time or something like that, maybe it's something that would be worth considering. But yeah, for the vast majority of applications, it's just way overkill, and the rotor coolant delete by itself works just fine. So it bolts on there just like the stock one would, apart from, of course, having the seal in it. So we'll go ahead and get our silicone laid down here, and then we'll bolt this thing into place. I didn't actually show it on camera, but worth mentioning, sometimes these holes can get some dried silicone in them from when the drive unit was originally assembled. It's not a bad idea to just go in there with a small, like a 3/16 inch drill bit, and just get any of that silicone out of there, so that when you bolt this thing down, your bolts don't bottom out on the silicone and then end up stripping your threads out. That's never a good time. So we'll just get our bolts in here. Alrighty, that's on. We can also go ahead and reinstall our side motor mount here. Alrighty, and now we're all done here. We can flip the motor back over and get our inverter reinstalled. Alright, so we're ready to get the inverter put on. I always like to, just as a kind of last resort, I have seen a handful of cases where the inverters do end up leaking from behind the O-rings here. There's really no easy way to detect that that ever becomes an issue without, of course, it causing a major problem. So I always like to add just a tiny little bead of silicone around the outer edge of the O-rings, just for extra precaution, just in case. And again, I'm just doing a very light bead. Nothing very heavy, but just enough to create an extra little bit of sealing here. All right, I've already checked that the inverter's nice and clean on the bottom. We'll go ahead and get it slotted on here. If I can get on the right side of the camera there. Okay, that's lined up pretty good there. Now we'll go ahead and install the fasteners for it in the center. My trick for doing this is I like to use one of these. It's kind of like a hex drive clutch drill, and I just set it to a 12. It just gets them kind of snugged up, and then I'll go back through and tighten everything by hand. Alrighty, so that's all bolted in. Now I'll go ahead and reattach all of our wiring. So this just runs through and attaches to all the ribs with little cable ties. And it just wraps all the way around and then plugs back in to the motherboard on this side here. Alrighty, now I can go ahead and install the 3 phase bolts here. And last, but certainly not least, we're going to go ahead and reinstall our splitter here for the inverter. So we've got some wiring that needs to plug in. This goes through here and plugs in to the board on the inside here. So does this one. There's this little bracket on the connector that we want to make sure the strap doesn't get trapped underneath, and that is in position. So we'll get that screwed down. Okay, now we'll get these tiny little screws that go into the voltage sense board. The little doohickeys on the board that these actually thread into like to snap off pretty easily, so just like to be really careful when installing these to make sure they don't twist. Okay, and now our final step is to tighten down the actual bus bar lugs. Alrighty, that's all good. So we'll take our inverter cover here and just slide that right down into place. Make sure our connector here doesn't get caught up on the edges. And we're on. So I'll tighten up the screws that go in here first. Definitely want to be a little bit careful with those. Does not need to be very tight, just snug. Now I can reinstall all the fasteners that go around the edges. There we go. The only thing we have left to put on here is our parking pawl servo. Which just goes like so. All right. And now this thing is totally assembled and ready to go back into the car. Alrighty, we've got the motor back on the transmission jack here, and we need to do a couple things before we can actually start getting it bolted into the car. First of which is we need to reinstall the crossover tube, which we couldn't do when it was on the stand because of course the stand clamps around the motor section and it's in the way. So we'll go ahead and get this back where it needs to go. I don't know if I actually showed removing this part before we put it on the stand, but that is one of the steps that we had to do. All right, that's on there. And now we also need to refill the gearbox oil. That can be done while it's actually physically mounted in the car, but it's easier to just do it while it's sitting right here. The way that I always do it is I just take out the fill plug, which is on there pretty dang tight. And then I'll grab my oil, and I like to just take just a piece of hose attached to a funnel, and I fill it right through the differential hole. It should take a little over 1.5 quarts of just Dexron 6 automatic transmission fluid. Real basic stuff. You can buy it anywhere. And there we go. So we'll get our plug back in here, hopefully without making too big of a mess. Get this out of the way. We'll tighten our plug back up on here. Make sure the drain plug is also tight. All right, and now we're ready to start reinstalling this thing into the car. Okay, we're just about in. Get our rearmost motor mount bolt started. Alrighty, so the drive unit is in. Now we can start making all of our final connections so we can hook up our cables, our data connector, our parking pawl servo, the coolant lines, all that good stuff. So anyway, we'll get started first with the high voltage cables. Can't really get these wrong since they're different lengths. But of course you want the negative to go to B minus, positive to go to B plus. And they just push right in there, like so. Now we can start working on reattaching our bracketry on here. Of course, this one, like I explained in part 1, you can't actually see all of the fasteners on here, so you kind of have to do it by feel for the ones on the top. All right, all that stuff is on. We can go ahead and put our little high voltage cover on here. And then our shield here can go on, which also has our data harness attached to it. So that plugs in. We've got a ground through this hole. There's all that stuff. Alrighty, on the other side here, we can go ahead and reconnect this coolant line. And we've also got our encoder sensor. We can go ahead and reinsert that. And we've got a fastener on our coolant line there that needs to go in. And we've got one more fastener for a little bracket here. We'll go ahead and get our clamp in place for the coolant line on the other side. And then we can remove our block-off clamps. All right, so electrically we've got everything hooked up in here, but we still need to get everything hooked up mechanically. So we've got to get our axles back in, and of course we still have some bracketry and stuff that has to go in as well. So let's get started on that portion. Alrighty, so if you'll remember from part 1, we were missing a fastener on the side motor mount over there. When I sorted through all the bolts, of course a whole bunch of them had been installed in the wrong places by whatever Toyota dealer last replaced this motor, which is not uncommon. I see that a lot. Like they had the bolts that go through here mixed up with motor mount bolts, bolts that go here mixed up with the bolts for the big structural member here, all sorts of stuff. But the bolt that was missing was actually not the one that was supposed to go in there. It was one of the ones that was supposed to go on this big crossbar on the bottom that's for crash protection. And it has a total of 6 bolts. So I was able to source a suitable replacement for one of those, albeit with a slightly larger head size. It's a 19 millimeter head instead of a 17. But it'll work just fine as a replacement for these. It's just an M12 fine thread bolt. So we'll go ahead and get that piece bolted back on where it's supposed to go. Alrighty, so we've got the car back down here. I'm going to go ahead and install the high voltage disconnect, and we'll reconnect the 12 volt battery and make sure that everything still works the way that it's supposed to. Alright, moment of truth. Will it run? Look at that, we're in ready, no errors. Apart from a low tire pressure, which I think this car might have a bad TPMS. We'll go into drive and see if it rolls. And look at that. It runs. So we'll go ahead and top up the coolant system and get the wheels bolted on. Put the plastic pieces back on underneath, and then we'll take this thing for a spin and see how it goes. All right, so we've got everything fully reassembled. Got most of the coolant system purged. There might be a little bit of air in there still, but that should work its way out with a short little test drive around the block. So let's go ahead and do that. Car is on. Let's go ahead and back out of here. Seems nice and smooth so far. Oh yeah, like butter. Smooth, quiet. Of course, this car surprisingly didn't really have much of any bearing noise to start with before. But yeah, this turned out great. Alrighty folks, that's gonna wrap it up for this one. Another job done. Like I said in the first part of this video, this is a job that I've done literally hundreds of times. So this is pretty routine for me to do a drive unit rebuild, particularly on one of these cars. But of course, I've done lots of them for Model S and Mercedes B-Class as well. Yeah, if you have any questions, leave them down below. And thanks for watching.